All right, y'all. So today we're going to be on page 32 and 33 of your packet, and we're going to be looking at adding and subtracting rational expressions. But this time we're going to be looking at when we do not have a common denominator. Okay, no common denominator. All right, and these are the steps that we're going to be using. And I do want to remind you that if it does have a common denominator, then these steps, you could still follow them, but you don't really have to do quite as much work because when they have a common denominator, you can go ahead and just combine like terms, factor, and simplify. And you can see this is a little bit more lengthy. All right, so either screenshot this or take a picture of the screen, something, because these are going to be the steps that I'm going to be referring to, but I'm a little bit limited on space, so I'm going to refer to the steps, but I'm not necessarily going to keep showing them on paper. All right. All right, so that brings us to number 7 on page 32, and you'll notice that we do not have a common denominator. Okay, so if I follow the steps, it says to factor the denominators if possible. Well, none of these denominators can be factored. All right, y squared, 3, and 6y squared. So I'm at step 2 where it says to determine a common denominator, and we're going to use each factor. Now, technically, these are all factors, all right, but this is y squared, this is 3, and this is 6y squared. So theoretically, 6y squared is kind of included in here as well, right? Because y squared is also here, and then 3 can be divided into 6y squared. All right, so when we get our common denominator, we want to try to get the least common denominator possible. All right, what could we use that all 3 terms could divide evenly into? And it would be 6y squared. All right, so now that we know our common denominator, step 3 says we're going to multiply all terms by that common denominator. And it says up top. So I'm going to multiply this term right here by y squared. This term here, oops, I messed up already, 6y squared, sorry. This term by 6y squared, and this term by 6y squared. So all 3 terms are being multiplied by the common denominator, all right? And now I'm going to cancel anything that can cancel. So I can cancel out my y squared and my y squared. Here, I can divide the 3 into the 6 to give 2y squared, all right? And then here, 6y squared and 6y squared completely cancel. So that's a hot mess, okay? So that's going to take some practice and some getting used to. All right, so now that I have canceled out all of my terms, all right, I'm eliminating the denominator, but only temporarily. Okay, so that's step 4. It says cancel out terms to eliminate the denominator temporarily. But now what we're going to do is we're going to figure out, well, what do we have left? And then we're going to combine those like terms in the numerator. All right, so what I have left here is 2 and a 6. So really that's 2 times 6. All right, well, 2 times 6 is 12. Plus. Here I'm left with 1 times 2y squared, and 1 times 2y squared is 2y squared, minus. And here I'm only left with a 5. All right, so I'm basically just rewriting what I have left to kind of clean it up, all right? And it says in step 5 to combine like terms in the numerator, and then it says to factor if possible. Well, 12 minus 5 is 7, and then plus 2y squared. So I like to put 2y squared first and then plus 7 just because I'm thinking about standard form. And you always go from the largest exponent and trickle down. All right, so this is my numerator. Now it says factor if possible. This cannot be factored. All right, so we're not going to have to do that. But then it says bring back the denominator and see if anything cancels. All right, so the denominator, remember, was that common denominator, the thing that we multiplied every single term by. So that is 6y squared. So I'm bringing back the denominator. And then can anything cancel from here? No. So this would be my final answer. All right, so let's take a look at another one. All right, so number 8, step 1 says factor the denominators if possible. The denominator that can't, or factors, is this one right here. So I'm going to factor that as x plus 2, x minus 2. All right, and I'm going to cross this out just because I don't want to rewrite the whole problem, so I'm just factoring that denominator. All right, now it says determine a common denominator and use each factor. So I have x plus 2 and x minus 2 and another x minus 2. Well, this x minus 2 is already accounted for right here, so I don't need to write it down again. I'm going to let my common denominator be x plus 2, x minus 2. So up top, I'm going to put x plus 2, x minus 2, x plus 2, x minus 2. So those are my common denominators, and I'm putting them on top, okay? But I'm technically multiplying this by this and this by this. So it's really multiplication, all right? So that is step 3. Multiply all terms by the common denominator, and you're putting them up top. Step 4 says cancel out the terms to eliminate the denominator temporarily. So in this first term, I'm canceling out x plus 2 and x minus 2. Notice that it literally canceled all of that out, leaving me with x squared minus 12, right? Well, in the second term, I can only cancel out the x minus 2's. Well, that leaves me with all of this right here, all right? So if you want to help save yourself some steps, then remember this is multiplication. So if I had 2 times this, what would I do? Well, I would have to distribute, right? So when you distribute, I get 2x plus 4. So plus 2x plus 4. Now, I still need to combine like terms, all right? So I would have x squared plus 2x minus 8. And then also in step 5, it says combine like terms in the numerator, but it also says and factor if possible. So this can factor. So this would factor and be x plus 4, x minus 2. Step 6 says bring back the denominator. So remember, the common denominator was the x plus 2, x minus 2. That's what we multiplied every term by. So kind of essentially what we're doing is, it's almost like, well, when we multiplied everything by that in the first place, now we have to bring it back and divide it out because we kind of have to undo what we did at the beginning. All right, so, and now that we have the denominator back, we're going to see if anything else cancels. So x minus 2 would cancel, leaving me with x plus 4 over x plus 2. So that is my simplified answer. If I wanted to know about extraneous solutions, it would be -2. All right, so that's number 7 and 8 on page 32. All right, so now let's flip over and we're going to look at number 9. And I'm on page 33. So again, it says factor the denominator if possible. So this is difference of squares. So I would have d plus 1, d minus 1. And we'll cross this out. And now I'm going to determine my common denominator. Well, d plus 1, d minus 1 includes this. So that would be the common denominator. So I'm going to multiply both terms by d plus 1, d minus 1. All right, both terms. Now I'm going to cancel out my terms. I'm on step 4 to cancel, and it's going to cancel out my denominators temporarily. So here, d plus 1 cancels d plus 1, d minus 1 cancels out, and that leaves me with just d. Now on the right side, d minus 1 cancels the d minus 1. All right, but I need to be careful because I have a minus d and I have a d plus 1. So this minus d has to get distributed to both of these terms. So that leaves me with a minus d squared minus 1. So be real careful about that distribution. And I can't combine any terms, but I can put this in order, right? So I would have a negative d squared plus d minus 1. Now, I don't know if you remember this, but we talked about this a lot, that we really want this leading term to be positive. All right, we want it to be happy. So I need to factor out a negative 1, which would give me positive d squared minus d plus 1. All right. Now I still have to continue to factor that, so I'm going to keep my minus 1, and I'm going to have a d minus 1 and a d minus 1. Let's see, nope, none of that works, right? So that actually does not factor. So I'm going to cross that out because that doesn't even work. All right, but this part is okay. I had my GCF. All right, but I'm at the last step where it says bring back the denominator and then see if anything cancels. So I'm going to keep this part, kind of give myself a little more space. So I have a negative 1 times d squared minus d plus 1 over d plus 1, d minus 1. All right. And at this point, nothing cancels because since this did not factor, then there wasn't anything I could cancel out. So because I'm leaving everything in this form, in factored form, then I would just be done. Okay, so my extraneous solutions would be negative 1 and positive 1. So if you look at number 10, this time we don't have to actually factor anything, all right, but we do need to go ahead and get our common denominator. There's nothing to factor. So since both of these are different, those are going to both become part of my common denominator. So my up tops, I'm going to multiply by x plus 1 and x minus 2. X plus 1, x minus 2. All right, so again, that's going to end up being my denominator in the end. All right, so I'm going to go ahead and see what cancels. So x plus 1 and x plus 1 cancels. That leaves me with x times x minus 2. I'm just rewriting it because it seems like it makes it a little easier. And then on the right side, x minus 2 cancels, leaving me with 8. So plus 8 times x plus 1. So maybe it's easier to see it that way. I'm going to go ahead and distribute. So that leaves me with x squared minus 2x plus 8x plus 8. I'm going to combine my like terms. So I get x squared plus 6x plus 8. Now I need to factor. So I'm going to have x plus 4, x plus 2. I'm going to bring back my original denominator, whatever I multiplied by up here. So x plus 1, x minus 2. And nothing cancels out, so this is my final answer. Again, I'm not asking you to remultiply that out. All right. So number 11. All right. Hold on, pause, because I'm actually fixing to be on a Google Meet with y'all. So I'm going to share my screen so that they know that I'm busy and that'll tie me over. Okay, so if we look at number 11, the only thing I can factor is this one right here, right? So that would be m plus 2, m minus 2. So m plus 2, m minus 2 will be my common denominator, but I'm going to have to put that for every single term. And it gets a little bit messy, but I'm going to start canceling anything that I can cancel out. So in this first term, m plus 2 cancels, and that leaves me with 3 times m minus 2 plus. In the second term, they both cancel, right? So that leaves me with just m squared minus. In the third term, the minus 2 part cancels, leaving me with a minus 1 times m plus 2. So I'm going to distribute. and see what I have. So I have 3m minus 6 plus m squared minus m minus 2. I'm going to combine my like terms to get m squared plus 2m minus 8. Now I have to factor, so I would have m plus 4, m minus 2, and then the last step is to bring back that denominator, whatever I multiplied by, right? So m plus 2, m minus 2, and then see what cancels. So these two terms cancel, and that leaves me with m plus 4 over m plus 2. My extraneous solution would be a negative 2. All right. The last example, I have to factor, so I'm going to have a minus 7, a plus 5, and then an a plus 4, and an a plus 5. All right, so this time my common denominator would be a minus 7, a plus 5, and then the only thing that has something different is the a plus 4. Same thing over here. So a minus 7, a plus 5, a plus 4. So everything gets used once. And now I'm going to see what cancels. So the a minus 7 cancels. The a plus 5 cancels. That leaves me with a 6 times a plus 4 minus, right? Here, the a plus 4 and the a plus 5 cancel, so I have a minus 2 times a minus 7. Now I'm going to distribute, which leaves me with 6a plus 24 minus 2a plus 14. Combine my like terms, so 4a plus 38. And I'm going to factor if possible, which I can only factor out a 2, so that would be 2 times 2a plus 19. Bring back my denominator, which is a minus 7, a plus 5, and a plus 4. And nothing cancels out, so this is my final answer. Okay, so again, bring it back to the steps. These are your basic steps. Okay, so if you didn't get a picture of that, this is what I've been following the whole time.